All right, good to have you back. I like to do a full polynomial factoring review. The entire thing. There are 5. I'm going to go through each one of these. The video will be about between 20 to 30 minutes long, maybe about 20, but this will be a comprehensive review, and this one video will take care of all of that. And don't forget to take the quiz that is in description below or in the pinned comment. Okay, let's start.
5x squared y squared plus 15x cubed y squared minus 10x to the power of 4 y. Let's write that express it as a product or factor this polynomial. So GCF first. Now from now on I'm not going to write GCF as a GCF anymore. We're just going to do factoring. So what is the factor? If you want to make a note here for the last piece, maybe we should do that one more time. The GCF of all 3 will end up being, so between 5, 15, 10. So 5 is the number, the coefficient, and then x squared, x cubed, x to the 4th. That would be x squared. That's the GCF of all 3, x squared and x cubed and x to the 4th. And then y squared, and y. The GCF of these is going to be y. All right, so we have, let's do this, 5x squared y is the GCF, and now we're going to go through this. What do we have to multiply 5x squared y to get first term? To get this back? Well, that's just multiply that by y. Great, plus. Next thing, what do we have to multiply 5x squared y by to get this, the second term back? Okay, and that is 3x and y, because 3 and 5, that will give you 15. 3 times 5, x squared times x gives you x cubed, and y times y is y squared. And then the last one will be 2, and there's a minus sign because that's a minus 10. And then the only thing that is y and y is there, that's already common. But then the x's, we have to only multiply the x squared by x squared to get the 10x for y. All right, and this is the factor form of the original polynomial. All right, another example. Let's call that example B. That was example A. Same idea again. This time our trinomial is based on m squared minus 6m plus 9. All right, so same idea again. Both brackets, we're going to open up both 2 brackets, and each bracket will have an m inside, and then we have to come up with the numbers that we're going to put in each of the brackets. So number 9 right here, the constant term of this trinomial, constant term that doesn't have any variable in front of it. So the 2 numbers you multiply, you get 9. There are not a lot of options. 3 and 3, that's the very first one. The next one is 9 and 1. But then remember at the same time is that you have to make sure the same 2 numbers you multiply, when you add them, you should get minus 6. So 3 and 3 will get 6, but not minus 6. But if you do minus 3 and minus 3, will get you minus 6. And the same thing with the minus 3 times minus 3, that will give you positive 9. So in this case, you will have m minus 3, m minus 3. And in this case, you actually have a perfect square trinomial. And the way you write it, because they're the same m minus 3 is showing up twice, you can write it as a compact form of m minus 3 to the power of 2. I want to show you another method, what I call it a grid method. So if you have m squared minus 6m plus 9 and you want to factor that, so to get m squared, you write m and m like that, and basically that's the bottom piece. You're going vertical like this. All right, and then for the 9, their option, now you're going to write down your option. So in this case 3 and 3, but because the middle term is negative, that's negative 3, negative 3. And so when you multiply, so coming down, you're multiplying it like that, right? That's what you're doing. And then so that would be 9 in here and m squared there. So the middle term matters now in there. That middle term is that when you do the crossing, so minus 3m, so that would be minus 3m, and then another minus 3m, so that will give you minus 6m. So therefore, and then the way you write it, you actually rewrite the whole thing as right across like that. So you write it as m minus 3 and then m minus 3.
A great way to factor a trinomial super easily and making it the simplest way that you can factor hard trinomials. Now, here's the first question. Now, as you remember, a regular trinomial that looks like x squared plus 5x plus 6, this trinomial is very easy to factor because all you need to do, you find two numbers, you multiply, you get 6, right? And then this multiplication of two numbers, and then the same two numbers, when you add them, you should get 5. Well, that's too easy. Just 3 and 2, and then that's basically it. You'll get that based on the positive and positive value. But then when you get a trinomial that has got a leading coefficient is not 1, you see that? But the leading coefficient here is 9. So you can't use this technique anymore. So you have to go through this trial and error, Chinese method, but there's even easier way. So here's the trick that you can do. First, you multiply 9 by negative 10, and then you're going to rewrite this as if there is no 9 in front. So that becomes x squared minus x minus 90. Now you're just going to employ the same technique as you knew before. Two numbers, you multiply, you get 90 minus 90, right? So, well, 9 and 10, that makes sense, right? Because that's pretty close. 9 and 10 gives you 1 or negative 1. So we can easily do that. So let's go ahead and factor. All right, now we're going to rewrite it now. We're going to rewrite this as the two factors. So this is what we're going to do. X plus 9, x minus 10. Now, what we need to do now, because we went ahead and multiplied everything by 9, remember originally we multiplied 9 by 10? Well, now we're going to go back and then do the division, okay? That's what we're going to do. We're going to divide the number part by 9. You're going to simplify this. Now, two ways to do this. Now you could just simplify and let's see what you get. And in this case, you don't get a fraction. That's good. But this one, minus 10 over 9, that's ugly. All right. So what you would do, you multiply x by that, and that becomes 9x minus 10. Okay. And by the way, these two, this and this, they are the same value. Both expressions are identical. You test that. You make sure that it works. So multiply through, you get 9x squared minus 10x plus 9x minus 10. Simplify, 9x squared minus x minus 10. Now, does this look like what we had? Sure it is. Look at that. Okay. Now, it looked like a long-winded kind of a solution, but the more practice that you have, the faster you will do it. And it will become much easier because you are very good at factoring regular polynomials or trinomials with a leading coefficient of 1. This is easy to grasp, so you just employ that if you want to. Now, if you still want to do a freestyle or the Chinese method right from the beginning or factor by grouping, you go ahead.
So in this case, what we will do is that we are going to use the vertical method to do the factoring. So we're going to get 3x squared. So that means that we must have 3x and x. Those are the only options that we can get 3x squared when we multiply them, okay? The next thing is that this number 10, we need to have two numbers that you multiply, you get 10. And then based on those two numbers, when you add them and then you manipulate, you should get 17. Now remember, this 3 does make a difference now. So it's not just simple of two numbers you multiply, you get 10, you add them, you get 17. That's not true. You have to do the crossing so that you can see what's happening. So the very basic one for 10 will be 5 and 2. And those are just the first option. I may have to change it. And then in this case, you notice that when you do a quick crossing, but when you add 5x and 6x, these two, you will not get 17x. So that means that 5 and 2 they are not the good option. So we got to come up with another option. So let's put 5 beside x and 2 beside 3x. Okay, let's look at this option. So we got 2 and 5 in here. So we're going to do the checking again. That would give us 15x when we multiply it across. And then we do the same thing with the 2. That would give us 2x. When we add these two guys, what do we get? 17x. Okay. So we got the factors. 3x plus 2 and x plus 5. Now, this is one method of doing it. There's another method. It's called factor by grouping. I'm going to show you guys that as well. The first thing you do is that you look at the 3 and 10, come up with two numbers. You multiply to 30 because 10 times 3 is 30. And the same two numbers add to the middle term 17. All right. So what are the two numbers? So 30 and 17. So it's very straightforward. So it seems that 15 and 2 works for both, because 15 plus 2 is 30 and 15 plus 2 is 17. 15 times 2 is 30. So here it is. Great. Now that you have 15 and 2, you break up the middle term, the 17x, the middle term, which is 17x, using these numbers. Okay, let's do it. 3x squared plus 15x plus 2x plus 10. And this is why we call this factor by grouping, because you're going to group them like that and factor each of the pairs. So for the first one, so I'm going to put it in a kind of a bracket like that and like that. All right. For the first two terms, what is the GCF? The GCF is 3x, open the bracket, you get x plus 5 plus. Second, for the second one, 2x plus 10, what is the GCF? Is 2. Take the 2 out, you get x plus 5. Now, so what is the GCF now? They've got to factor that again. All right, so factor. So this is called factoring, right, for each pair. And we're going to factor it again. In this case, what is the GCF? Is x plus 5 and x plus 5. So it would be x plus 5 out, and then the 2. So for a first term, x plus 5 times 3x, plus, we want to get the second term, x plus 5 times 2 will give us the second term. And that is another way of factoring this. And if you check, you notice that 3x plus 2, x plus 5 is right here, 3x plus 2, x plus 5. And it doesn't matter which one it comes first, which one's second. In terms of the x plus 5 and 3x plus 2, you can have the x plus 5 first if you want to. And that's how you do that. This is called factor by grouping. Okay. All right, first, what is difference of squares? Well, I just put down x squared minus y squared to kind of explain to you what the difference of the squares mean. Well, each of these guys are perfect squares, right? X squared is a perfect square, so that's the perfect square, and y squared is a perfect square. And this minus sign in between, that's the difference. That's why we call it difference of the two squares. All right, we need to be able to, at one point, to put it into a factor form. And remember, factor form, writing the polynomial as a product, as an expression of a product, okay? And that's what we're going to be doing, that each of these brackets will have two terms in them, and x and y and x and y, and you want to see what's happening with that. Okay, let's go through a couple examples. First one, x squared minus 49. We want to factor that. Let's see what happens. So first we have to make sure that both of them are perfect squares. X squared is a perfect square and 49 is a perfect square, and there is a negative in the middle, so that's a difference of squares, and then we can use this factoring pattern. So here it is. We say this is, so both brackets, you open up two brackets, both of them will have an x and x in there. We'll have a 7 and 7 because the square root of 49 is 7, or 7 times 7 is 49, and then the first one is negative, the second one is positive, or vice versa, by the way. It doesn't matter. You can start with the positive and then put the negative in the second bracket, but that is it. Let's look at example B. Same idea again. Let's first check perfect square, numbers, and the variables. So that is two brackets opened up. First one will have a 9y in there, and so as the next one. And the second part of each of the brackets will have a 4x and 4x, because 4x times 4x is 16x squared. And then next, the first one I'll put minus, the second one plus. I got used to doing that, but you can start with the positive first and the negative second. All right? Okay, so let's look at this question, example C. Same idea again, but this time, when we check for the perfect square, you notice that 8m squared and 72, they are not perfect squares. All right, so the first thing we have to do always, that you check for GCF. If there is a GCF, doesn't matter what kind of a factoring question you have, you always check for greatest common factors of all terms, so you take that out first. And once you do that, then whatever you are left with, then you can look at it and say, okay, what type of a trinomial it is or binomial it is, and then you go ahead and you factor that inside the bracket. So in this case, we know that factor 8 is a common factor for both, the greatest common factor. Take that out, will give you m squared, and then 8 out of 72 is going to be 9. Look what's happening here, m squared minus 9, that's a perfect square now. Okay, so that's a difference of squares. We can factor that, and that's what you will get. Okay, example D, this should say 28b. So same idea again, check for GCF first, because neither one of these guys, they are perfect squares. So the GCF of both of them, 7b, that goes, that's the GCF, and take that out, and you will end up getting 9a squared minus 4. And for the purpose of this, so 7b, you leave the 7b alone. Inside 9 squared minus 4, that's a difference of squares. So now you can just go right ahead and factor using a difference of squares. And so 9 squared becomes a 3a and 3a for each of the brackets, and 4 is a perfect square as well. 2 and 2 for each of the bracket. Make sure the signs are changing. All right. So example 1, we're going to factor 3x times a plus b plus 5 times a plus b. See what is common between both these terms. So these are the two terms. What do you see that is showing up in both of them? There is no x for the second term, but look what else it has. A plus b in here and a plus b on the second term. That is your GCF. So GCF is a plus b. There's nothing wrong with having a binomial as a GCF. So when we do this, so you take the a plus b out and then open a bracket, because it's a multiplication. Remember, when you're dealing with the factoring, means you're writing it as a product. All right, so ab for the first term times 3x will give us the first term plus, and then the second will be 5, because 5 times ab is 5 times a plus b. Okay, 5, so a plus b, that's your GCF. Multiplying it by 3x will give you the first term. You multiplying by the second term give you the second term, and that is it. All right, example B. we have this trinomial. What is the GCF? Let's deal with the numbers first. We have 12 minus 8 minus 20. So in all of these cases, you notice that 4 is the number for the coefficient for the GCF. Okay. And now between m, and m squared, m is the GCF that goes into all of them. And then between n and n squared, n is the GCF. Open the bracket. Now start doing a multiplication. We need to have 3 terms inside. So 4mn times 3n, that will give us the first term. Okay, that's the first term. Minus 8 and 4, that would be 2. Mn is already included. I don't have to write that anymore. So 2 is on its own. Very good. Minus again. And then 20 and 4. So 5 times 4 is 20. And we have m squared on top here. We have m there. So we have to multiply by m. All right. So that's what we have done, by the way. Right. So here it is, one term at a time. And that will give you each of these terms back, right? That's the term back. That's the term back. All right. And that's your final answer. 4m and open the bracket, 3n minus 2 minus 5m. And that would be it.
And this was the full factoring review for this unit. Make sure you check out the quiz in the description below or in a pinned comment, and check out the next review of a concept in any of the math classes and courses. Okay, until next time.